Welcome to Homework Lib.
This is chapter 35, problem number 28. We have a plastic film on the glass to increase the reflection to cool down a car. So we have air, and then the film, the plastic film, and the glass. The index of refraction of glass is, let's see, glass is 1.52. And film is 1.7, and air, as you know, it's much lower than these two. So let's look at the phase change upon reflection from the upper portion. Then we're going to have 180 degrees phase change, but in the lower interface we don't have any. So overall phase change is 180 degrees. And we want the constructive interference to happen, right? That's what it says in the problem. So then our equation is going to be twice the thickness equals m plus 1/2 lambda in this particular medium. So then lambda in vacuum or air divided by n film is going to give us this lambda. So then 2t is going to be equal to m plus 1/2 lambda divided by n film. Divide both sides by 2. Then we have the thickness to be m plus 1/2 lambda naught over 2m film. Now, we're looking at the minimum thickness, so m is going to be 0. So if m goes to 0, then the thickness is going to be simply lambda naught over 2 times 2, 4 of the m film. And lambda is given to us as 550 nanometers. So I just converted it into meters. And film is 1.7. From here, we find the minimum thickness to be 80.88 times 10 to the negative 9 meters, which gives you 80.88 nanometers. This will be the answer to part A. I'm going to put the part B here because it's really short and straightforward. Part B, we're looking for the next thickness where we would get the constructive interference. So then it's going to be m equals to 1. Using our same equation this time, well, let's go here, right? Let's use this one. Instead of taking m equals 0, we're going to take m equals 1. So the thickness is going to be 1 plus 1/2 lambda naught over 2m film. So then 3 over 2 lambda naught 2m film. This is basically 3 times the answer, right? Because we already calculated this part. It was 80, so 80 times 3 is going to be 242.65 nanometers.